Student, today we are going to discuss another most important type of corrosion, that is pitting corrosion. The name itself will tell you some idea. Pit, it is confined to a small place, that is why it is known as pit. This is actually localized type and it occurs on the metal surface confined to a small point or a small area which make the form of cavities. Another term is their pitting factor, which may be defined as the ratio of the depth of the deepest pit which is resulted due to corrosion divided by average penetration, which can be calculated based on the weight loss. Now we have to see what is susceptibility, susceptible metal or metallic structure which are susceptible to pitting corrosion. This type of corrosion is often found in metal or metallic products made of actually passive metal like aluminium, aluminium alloy, stainless steel. This is because the destruction of ultra-thin passive oxide layer, which is being damaged due to chemical or mechanical exposure, and those damaged area will not get rectified or repassivated immediately. As a result of which, the pit may actually take different kind of shapes which are represented here. It may have narrow deep shape, it may have elliptical shape, it may have the shape of wide shadow, it can be surface type, it may be actually undercutting and horizontal, and last one is vertical type. You can understand by name itself, if it is vertical, it means it is going vertically, it is expanding vertically. The pit is expanding vertically, and if it is horizontal, it is expanding horizontally. Because of pitting corrosion, these different 7 types of different kind of cavities may be resulted. Now we will be discussing on the mechanism of pitting corrosion. If we want to discuss the mechanism, we have to divide it into 3 categories. Number 1 is for a defect-free structure or material. What I want to mean, if a metallic structure is made of a metal is defect-free, there is no defect at all, here also corrosion may proceed. But here the corrosion will proceed by environmental condition, type of attack. As environment may contain some aggressive chemicals like chloride, and this chloride ion is particularly very damaging to the passive oxide layer, as a result of which pitting corrosion will start at the point of destruction. I repeat, if your metal or metallic structure is very much defect free, there is no defect, then pitting corrosion will proceed by environmental phenomena, as environment may contain some aggressive chemical like chloride ions. This chloride ion is particularly very damaging to the passive oxide layer, and pitting corrosion will start getting dangerous slowly, starting from the damaged oxide. Now, second one is, suppose your structure is mechanically, the structure is absolutely defect free. Chloride ion is not there. In that situation, the environment may cause this pitting type of corrosion by developing differential aeration cell. Suppose it is a steel product, let it be like that, and if there is a droplet, water droplet, now droplet, the center of the droplet will become your anode because oxygen concentration will be minimum. This part will be maximum oxygen, and therefore a differential aeration cell will be produced, resulting pitting corrosion. And that is why we have told that if actually there is no chloride ion is present in the environment, even then by making differential aeration cell, corrosion may proceed, pitting type of corrosion may proceed actually through this phenomena. Now suppose your environment is homogeneous, but your metallic structure have some defect, as in the case of steel. If it is a steel product, you know that there may be impurities like manganese sulfide. Now, if manganese sulfide is present as impurities in a steel article, it is going to initiate pitting corrosion without any doubt. This is all about the mechanism of pitting corrosion. And now let us talk about the factor affecting by influencing pitting corrosion. Here, one thing we would like to discuss. If a metallic structure is placed anywhere, there is huge amount of possibility of aeration. Free aeration is there. Then, due to this aeration, there is a free possibility the rate of oxidation will go faster, as a result of which oxide layer will be formed and it will heal or reprecipitate the broken oxide. And particularly this phenomena is possible if it contains alloying element like molybdenum, chromium, titanium. This is all about your factor influencing your pitting corrosion. Now how can you control this? So you better understand that if we want to control pitting corrosion right from the beginning, we have to ensure that selection of material is proper. We have to maintain pH and temperature, and we have to ensure that the metal or metallic structure being exposed should be free from chloride ion, and by offering cathodic and anodic protection, pitting corrosion can also be controlled. What is actually anodic and cathodic protection? It will be discussed in detail when we will discuss corrosion control. This is all about your pitting corrosion. Now we are going to discuss another important type of corrosion, that is waterline corrosion, which is very relevant also. Waterline corrosion. You can understand that by name itself. Actually, this type of oxidation type of corrosion occurs when a metal or metallic product is in contact with water. And this type of corrosion occurs when part of the metal or metallic product is immersed under water and remaining part is exposed to the environment, as a result of which a differential aeration concentration cell will be produced. Let us take one example. Suppose it is a container, this is water, this is an iron rod. Now you see, this part is immersed under water, and this part is above water in contact with air, and therefore the part just below the water level will have less oxygen content compared to this area, and therefore this part will become very, very active. As a result, it will become your anode. making this part cathode. Now electrochemical cell is developed. So this kind of corrosion, electrochemical differential addition cell will be produced, as a result of which corrosion will take place just below the water level. Corrosion of this type is known as waterline corrosion. We know that in industry we use big tank for different storage purpose, and if we want to store some industrial liquid or any other solvent like water, so there is a possibility this kind of corrosion will take place. May fall victim of this type of corrosion because of the complete structure failure. Any ship is kept stagnant for a long time, there is every possibility waterline corrosion may be developed. And ocean-going ship is always associated with this kind of problem of waterline corrosion. This kind of corrosion is associated with distinct brown line just below the water level. Now let us talk about the control. If we want to control this kind of corrosion, the best option is that we have to provide suitable coating, and most importantly we can use selective metal which will be much more resistant towards this kind of corrosion. In this situation, stainless steel and aluminum are the best option. These are all about your waterline corrosion. Please go through the video very carefully. In case of any doubt, get your files noted. We'll be clearing your